What is embedding and why it's the foundation of language AI? How does AI understand words? Imagine you tell your phone to find a picture of your dog. You immediately picture exactly what you're looking for, but how does your phone understand what you're saying? Does it truly know what a dog is, or is it just guessing? Today, we're diving into one of the most essential concepts in AI, embeddings. How do we take words, like dog, and translate them into something an AI can understand? And why are these embeddings the foundation of language AI? Stick around to find out. Why words alone aren't enough? Let's start with a simple question. How do humans understand words? For us, language is intuitive. When we hear the word bat, we understand the context. Is it a flying mammal or baseball equipment? Humans use context to figure out meaning. But AI doesn't have that luxury. It can't intuitively process the word bat without extra help. AI doesn't understand words the way we do. To process and make sense of language, it needs a system, a way to break down words into something more structured. Without this ability to grasp meaning, AI would just see random strings of text with no understanding. This is where embeddings come in. Embeddings are the method AI uses to transform words into vectors, which are essentially lists of numbers that AI can process to figure out meaning. These numbers allow AI to understand semantic relationships between words and how they're used in context. So, what exactly is an embedding? Simply put, an embedding is a vector, a numerical representation of a word in a high-dimensional space. Think of it like a map of meanings. Each word is placed in a specific spot based on its meaning and how it relates to other words. For example, the word apple might be closer to fruit and banana than to a word like car. Embeddings help understand the relationships between words based on their context. AI understands numbers better than words. By converting words into vectors, AI can process and compare them mathematically. This allows AI to capture deeper semantic relationships, like how king is related to queen or man to woman. How embeddings are formed. Now, how are these embeddings created? Initially, the vectors start off as random numbers. In the beginning, these vectors don't have much meaning. They're just numbers tossed together. But as the AI trains, the vectors begin to adjust based on how words are used in context. Think of it like this. If the words dog and cat appear in similar sentences often, the AI learns to bring their embeddings closer together in the vector space. The closer the vectors are, the more similar their meanings. As the AI learns, it refines the vectors, improving the semantic understanding. This process happens during training, where the model uses backpropagation to adjust the vectors, improving the AI's understanding of each word's meaning. 2D embedding space. Now let's visualize how embeddings work in practice. Imagine taking high-dimensional embeddings and reducing them to a 2D plot. Though in reality, word embeddings exist in hundreds of dimensions. We'll simplify it to just 2 for illustration. Words like cat, dog, and pet are semantically similar, so their vectors are close together. Meanwhile, car, truck, and vehicle are grouped separately. The key point: similar words are closer together in this 2D space. Techniques like TSNE and PCA, principal component analysis, are used to reduce high-dimensional vectors into 2D or 3D for visualization. But the core idea is simple. Words with similar meanings should be close together. Why embeddings matter? So why are embeddings so important? They're the backbone of modern language models. Without embeddings, AI wouldn't be able to perform tasks like translation, summarization, question answering, or even sentiment analysis. Google Translate, for instance, uses embeddings to translate words between languages. Without embeddings, it would be impossible for the AI to recognize the relationship between words in different languages. Embeddings also allow AI to perform contextual analysis, helping AI determine the meaning of words with multiple interpretations based on the surrounding words. This is crucial because language can often be ambiguous. The future of embeddings and AI. Embeddings are the foundation of how AI processes and understands language. They allow AI to transform words into meaningful vectors, making it possible for it to perform a wide range of language tasks, from translation to sentiment analysis. Next time, we'll take a deep dive into transformers, the next step in AI's ability to understand language in context. Stay tuned, and don't forget to subscribe for more insights on AI.